Question 27a. At a particular time during the day, a tower of height 19.2 meters casts a shadow. At the same time, a person who is 1.65 meters tall casts a shadow 5 meters long. What is the length of the shadow cast by the tower at this time? So this is a question that's based around similar triangles, and I want you to notice here we have the large right angle triangle, okay, and that is similar to the small right angle triangle. What that means is that the corresponding sides are all in the same ratio. But it also means that sides relative to each other are also in the same ratio. So in other words, 1.65 to 5, so let's write this ratio down, 1.65 to 5, and I'll write it as a ratio, so using the correct notation, is equal to 19.2 to this sort of the length of the shadow. So 19.2, let's call it x. Okay, so let's call that the length of the shadow x. So let's solve this. 1.65, we will solve it by treating the ratio as a fraction. 1.65 over 5 is equal to 19.2 over x. Now, the x is in the denominator. When you're trying to solve for a pronumeral, it's nice to have that in the numerator. So we can, in fact, we could flip both of these fractions. So why don't we do that? So in other words, 5 over 1.65 is equal to x over 19.2. What you do to one side, you do to the other. Okay, so if you invert both fractions, you haven't changed the integrity of the equation. I mean, the left-hand side still equals right-hand side. Now let's make x the subject of the formula. We're going to move the 19.2 over to the other side. So let's do that. So 19.2 multiplied by 5 over 1.65 is equal to x. So let's evaluate the left-hand side. I'll just brighten the display a little bit there. Okay, so 19.2 multiplied by 5 over 1.65, and we get 58.18. So okay, and let's see if there's any rounding required. No rounding required, so we could leave it to correct to 2 decimal places.